Hey, Algebra 2s. I hope you're doing okay at home. So here's this first part of the Algebra 2 review packet. It's an interesting one because it talks about investigating functions. So it gives you each of the different types of functions that we've talked about. And it's interesting, they start with rational functions, which feels like it's our most recent unit. If you go to the back of the activity, they talk about an extension using a graphing utility, which I'm assuming they mean the TI 84, graph each of the 12 functions above individually. So when we're talking about what I'm graphing with, whether you do TI or Desmos is up to you. Graph each of the 12 functions individually, state the domain and range, and describe the end behavior. I'm just going to include that in each of these things because understanding our domain and range is an important conversation, and our end behavior also. So if you are checking in after you've already done this, go back and do these things because that's what I'm going to be adding to my conversations here. Remember, you learn best if you do and think first, and then you watch and check. So we want to make sure that you're using that big brain of yours and thinking about this stuff before you're just copying down mine. That's why you're here. I'm glad you're here. I'm glad you're watching. Okay, so we'll go ahead and we'll start talking about our first function. I'll grab my TI and let's see if we can. There we go. We'll move it over. All right, so second num 712. We'll go ahead and we'll look at our first function. We'll go into y is equal to. It's so important that you include parentheses in what you're doing so you can make sure that that's a clear numerator and that's a clear denominator. So when I graph it, of course, I see asymptotes. Now I know that my first asymptote is going to happen at x is equal to -3 because that's where this graph has a value of 0 in the denominator. When I talk about my horizontal asymptote, that's going to be at the location because I have the same number of x's above and below. I'm going to look at the fraction of their coefficients. Talking about my x and y intercepts, your x-intercept is going to happen when the numerator is equal to 0. So when I set x is equal to, x plus 2 is equal to 0, and I go ahead and solve for x, I wind up with that conversation where I have an input of -2 gives me an output of 0. And for y, the easiest thing is to go to the table of values and say an input of 0 is going to give me an output of that decimal, which is 2/3. When we talk about discontinuity, we really haven't talked about that a lot, but what we want to know is when we're talking about where it is discontinuous, that means where do I have to pick up my pencil? Where does my graph end up? Is there a point that I either jump or that the graph stops at? So for here, my asymptote is going to be that conversation. So there's not a particular point, so we're not going to worry about that at this point in time. All right, so when I go ahead and I think about my domain and range, we'll go ahead and recognize that my domain is going to be all the values from -infinity up to my asymptote, and then from my asymptote on, I'm going to recognize that my range is going to be all the values from my -infinity up to my asymptote at +1, and then on after 1 on to infinity. It's really important that you think about the relationship between each of these values. This vertical asymptote creates this domain, and understanding that relationship between them. All right, so they also started to ask us about end behavior. So we'll talk about as x approaches positive infinity, y is going to approach, and remember, they always approach your horizontal asymptotes, which is going to be 1. And as x approaches negative infinity, we recognize that y is then also going to approach 1, but from the negative direction. All right, let's take a look at number 2. All right, so we'll take a look at our second one. Now, when I look at this first function, what I see here is an equation that we have not yet closely looked at or talked about. And this is when we have more x's in the numerator rather than the denominator. So if we remember, when we talk about our horizontal asymptotes, we have 3 different scenarios for horizontal asymptotes. Number 1, if I have more x's in the denominator than the numerator, y is equal to 0 is my horizontal asymptote. Number 2, if I have the same number of x's in my numerator and denominator, then that's when my horizontal asymptote is going to be the fraction of their coefficients. This third scenario that we haven't really spent a lot of time talking about is when there's more x's in the numerator than the denominator, and we've just been told that there's no horizontal asymptote, but we haven't really talked about why. And if you enter this equation into your calculator and look at the graph, it's a little bit confusing because you're like, hey, that's a squared. Why is this a straight line? Why is this a linear looking graph? And it has to do with the fact that we need to factor our numerator and understand how we end up with something in our numerator and our denominator that cancels out. So what you're looking at here is the graph of x plus 3. So when we look at the graph, we have x and y intercepts. We have the fact that my x-intercept is going to be the input value that makes this output equal to 0. And if we go to our table of values, you can see that when a 0 goes in, a positive 3 comes out. But now this is where we really get to talk about this discontinuous points, because do you see this error here? Are you curious about why that happens? Well, the reason that happens is because of this factor that cancels out. We can't have an input of 3 because what ends up happening is I end up with a 0. I end up with a 0 as an output. So we can't really see it on the graph, but an input of 3 is going to give me that output of 0. So what would be here, 3, 6, is actually not actually a possible point on my graph. When I look at the table of values, I know where it should be happening right here, but I know that it doesn't because when I go back to my original equation, that's a problem. All right, when I look at my vertical and horizontal asymptotes, there are none because of this third scenario. So now let's go ahead and talk about our range. Our domain is going to be all the values from negative infinity up to, guess what? That 3 is a no-go. So that 3 is going to not necessarily be a vertical asymptote, but it still will be a point that we cannot have as an input. So our range is going to be, we can't have this 6 as an output. You can see on the calculator how we have all the output values going on and on and on forever in this direction, and all the output values going on and on and on forever in this direction, except for that one. So our range values are going to be negative infinity up to, but not including 6, and then continuing on forever. When I look at my end behavior as x approaches positive infinity, when I look at this graph, so does y. As I look at x approaching negative infinity, guess what? So does y. So that's a new conversation for us. We haven't had that, but now you know what ends up happening when I have more x's in the numerator, no horizontal asymptote, but I do have the possibility of this discontinuous point. All right, let's take a look at our next one. We'll pause and take some time to enter that into the calculator. Okay, so let's go ahead and take a look at number 3. I have 2x squared minus 5x minus 12. I factor that into 2x plus 3 times x minus 4. That needs to be a minus 4. I can double check my math. 2x times x is 2x squared. And then I have negative 8x and positive 3x. And then I have negative 12. So that will work. Here's the difference of 2 squares, and that factors into plus 4 and minus 4. So when we're talking about my x and y intercepts, my x-intercepts are going to be my zeros of my top. So when I talk about what inputs give me outputs of 0, I'm going to have negative 3 halves is going to be a 0 here, and then positive 4 is going to be a 0 there. When I talk about my vertical and horizontal asymptotes, notice this ends up canceling out. And when this function ends up canceling out, it does give me that discontinuous point of x having a value of 4. So we'll go ahead and check out that in the calculator. When I see x as an input of 4, gives us an output that we're not going to be able to estimate or have, 1.3-ish, if I look at that pattern. When I have my vertical and horizontal asymptotes, I still have a conversation here where I have one horizontal or vertical asymptote at x is equal to negative 4. And because my coefficients are the same, I wind up with a horizontal asymptote at y is equal to positive 2. When I start looking at my domains and ranges, I am going to consider, as I look at this graph, what my values are and are not allowed to be equal to. So for my domain, I'm going to have negative infinity up to and including or not including negative 4. Hopping over that and going up to, don't forget about this 4 up here that's not allowed to be an input. So I can go up to that 4 and then skip over that and on to infinity. When I talk about my range values are going to have negative infinity up to this horizontal asymptote, which is going to be at 2, with the union of 2 up to. Now I need to figure out what's going to happen at this point here, because without this point, I don't know where we're going to then stop and start again until I go to infinity. So when I have to figure out this discontinuous point, I'm going to have to substitute into this equation and see what my story is there. So when I go ahead and I put an input of 4 into this function, I wind up with the following math. So I'll have y is equal to 2 times my input, which is 4, plus 3 over my input of 4 plus 4. So my y is equal to, that's 8 plus 3 is 11 over 8. So remember when we had talked about our table of values, saying that that would happen around 1.3. Let's go ahead and see how close we are. 11 divided by 8 looks about right. So we're going to go ahead and put in 11 divided by 8 into that value anyway, recognizing that we can come up to and hop over 11 divided by 8 and then continue on to infinity. Right, now we're going to talk about our end behavior. And again, taking a look at our graph ends up being our greatest conversation, because notice everything always goes towards our horizontal asymptote. So we can say as x approaches infinity, positive infinity, y is going to approach our horizontal asymptote. And as x approaches negative infinity, guess what? Y is also going to approach our asymptote. Okay. All right, so let's take a look at number 4. We have f of x is equal to 5 over x minus 6. So we'll go ahead and enter this one into the graphing calculator. And we'll say 5 divided by parens. Make sure you're using your parentheses. Without your parentheses, you run the risk of the calculator taking over order of operations for you. Okay, so let's talk about our x and y intercepts. So our x-intercept here is going to be where it crosses my x-axis, and then we're going to say that that's none, because this fits my first scenario of my asymptotes. My asymptote here is going to be x is equal to 0, or y is equal to 0, because I'm not going to ever touch that x-axis, so it's none. When I look at my y-intercept, a 0 goes into the function and negative 0.83 comes out. My vertical asymptote is going to happen when my graph is, when my denominator is equal to 0. So there it is. Let's talk about domains and ranges. For my domain, and as I look at my graph, this can help me. So all the values of x from negative infinity up to my vertical asymptote, hop over that asymptote, and continue going on. For my range, same story. Negative infinity up to that horizontal asymptote at 0, hopping over it, and continuing on. There is no discontinuous points, so we'll put a none in there. Let's see. As x approaches positive and negative infinity, as x approaches positive infinity, y is going to approach, don't forget, it's going to approach your horizontal asymptote at 0. As x approaches negative infinity, guess what? Y still approaches 0. Okay? Let's take a look at this last one for this video. We're going to go ahead and take a look at x and y intercepts, and here's this rational function. Make sure that when you graph this rational function, you are wrapping these up in parentheses. X plus 2 divided by, and we have x squared minus 4. Now I already know that's a difference of two perfect squares, and so I'm going to be factoring something out. Let's take a look at what happens to my numerator. Yeah. But we know that there's going to be an extra point that we need to take care of, because there's going to be a discontinuous point. So I know that this factors into x plus 2 over x plus 2, x minus 2. So when I look at my horizontal asymptotes, I know that these cancel out. So my one asymptote is at x is equal to, oops, wrong one. So this one's okay. X is equal to positive 2 is my first asymptote, but I know I'm going to have a point of discontinuity here at negative 2. I can test that by going to my table of values. Yep, there it is. All right, so when I talk about my x and y intercepts, because this ends up being a graph where this cancels out and I have 1 over x minus 2, I go back to having a horizontal asymptote at 0. So for my x-intercept, we're going to have none because that's my asymptote. For my y-intercept, we'll go to the table of values and say, hey, when 0 goes in, what comes out? And that's going to be negative 0.5. We still have to figure out this discontinuous point. So we'll go ahead and we'll solve our fraction. We'll take f of x is equal to 1 over x minus 2, and we'll go ahead and put that value in. 1 over negative 2 minus 2. So we'll have 1 over negative 4. So we'll say that point of discontinuity is going to be negative 0.25 or negative 1/4. We can know that that, of course, makes sense when we look here. That negative 0.25 would fit into that pattern for sure. Okay, let's talk about our domain. It's going to be negative infinity up to my point of discontinuity. My point of discontinuity up to my asymptote, and my asymptote on to infinity. And for range, negative infinity up to my point of discontinuity, my point of discontinuity up to my asymptote, and my asymptote on to infinity. Now we have our end behavior here. So we can say as x approaches infinity, y approaches, and I'll go back to my asymptotes, y approaches 0. And as x approaches negative infinity, y also approaches 0. All right, that's page 1. We'll take a break and make page 2 our second video.